Hello, viewers. In today's session, we are going to discuss a very important and conceptual problem from limits. And here we have to discuss this limit, that is limit x tends to 0 and greatest integer of x raised to 10 minus 10 divided by 20 minus greatest integer of x raised to 20. So here we have a very interesting problem, right? So what we will do here, we'll see whether the limit exists or not. So for the existence of this limit when x tends to 0 and we have this function, we have to find out the right hand limit and the left hand limit when x approaches to 0, right? And we'll see whether the right hand limit is equal to a left hand limit, right? So let us first calculate the right hand limit. So let us first take this function as f of x, right? So the right hand limit is given by a limit x tends to 0, and here we have a positive sign, and here we have f of x, right? So this is the notation for the right hand limit when x approaches to 0 from the right of x is equal to 0, because see here we have the point x is equal to 0, and when we approach towards x is equal to 0 from the right of x is equal to 0, then we have a point in the neighborhood of x is equal to 0, and that point is 0 plus h, right? This point is 0 plus h, and when we calculate the left hand limit, we approach towards x is equal to 0 from the left of x is equal to 0, right? And we arrive at a point which is in the neighborhood of x is equal to 0, and we say this point is 0 minus h. And remember, this h is a positive quantity that is greater than 0, but it is less than 1, and h is infinitesimally very small. So now here we'll take x is equal to 0 plus h, right? This point is 0 plus h, and 0 plus h is simply h. And when x approaches to 0, then obviously h approaches to 0. So now writing this limit in terms of h, we have limit h tends to 0, and here we have for x we can write 0 plus h or simply h. So we have f of h. So now we have limit h tends to 0, and f of h may be obtained by replacing x by h, right? So we have greatest integer of h raised to 10 minus 10, and then we have 20 minus greatest integer of h raised to 20, right? Okay, so now here what we will do, we'll calculate the value of the greatest integer of h. Now this is an important quantity, and here we cannot directly substitute h is equal to 0 as we usually do while solving the problems based on limits related to algebraic expressions, right? So whenever we encounter greatest integer function or the fractional part function, we cannot directly substitute h is equal to 0 as such, right? So what we will do, we'll write the value of greatest integer of h, that is simply equal to 0, right? Because h is infinitesimally very small, and remember h is very close to 0, so it lies between 0 and 1. So the greatest integer of h should be equal to 0. So now we can write limit h tends to 0, and here we have 0, so we have 0 raised to 10 minus 10, and here we have 20 minus 0 raised to 20. So this quantity is 0, and we can now omit this limit notation because this expression is independent of h. It doesn't contain h. So we have simply 0 minus 10 over 20 minus 0, that is minus 10 over 20, that is equal to minus half, right? So the right hand limit of this function when x approaches to 0 is minus 1 over 2. Now let us find out the left hand limit. So the notation for the left hand limit is limit x tends to 0. Here we put a negative sign, then we have f of x. Now, when we find out the left hand limit, we take x is equal to 0 minus h. And here 0 minus h is minus h. And when x approaches to 0, then obviously h also tends to 0. So now we can write this limit in terms of h. So we have limit h tends to 0, and here we have f of minus h because x is 0 minus h and this is minus h. So now we can write limit h tends to 0, f of minus h can be written with the help of this expression for f of x by replacing x by minus h. So we have simply greatest integer of minus h raised to 10 minus 10, and here we have 20 minus greatest integer of minus h raised to 20, right? Okay, so now as we have just explained, we cannot directly take h is equal to 0 in this expression, right? So what we will do, we'll first calculate the greatest integer of minus h which appears in this expression. So see, h lies between 0 and 1. So if we multiply this inequality throughout by minus 1, we'll get 0. The direction of the inequality get reversed. So here we have minus h, then we have minus 1. So we can again write this inequality as minus 1, minus h and 0. So this indicates that minus h, it lies between minus 1 and 0. So when minus h lies between minus 1 and 0, then the greatest integer of minus h should be equal to minus 1, right? So we should remember that greatest integer of h, that is positive h, is always 0, and greatest integer of negative h is equal to minus 1. So we have here limit h tends to 0. Here we have minus 1 raised to 10, then we have minus 10 here, then we have 20 minus minus 1 raised to 20. So now since this expression doesn't contain h, so we can remove this limit notation, and we are left with only this expression containing numbers. So minus 1 raised to 10 is simply plus 1. Here we have minus 10, then we have 20, and minus this is plus 1, right? So now we have 1 minus 10 is minus 9, and this is 20 minus 1, that is 19, right? So the left hand limit of this function when x approaches to 0 is minus 9 over 19, and the right hand limit we have just calculated that this is minus 1 over 2. So now we can see that although the right hand limit and the left hand limit both exist and they are finite, right? So these are the finite numbers, but here the right hand limit is not equal to the left hand limit because minus half is not equal to minus 9 over 19, right? And for the existence of the limit of a function at a given point, the right hand limit and the left hand limit should be finite and they should be equal to each other. So in this case, although the right hand limit and left hand limit are finite and they exist, but they are not equal to each other. So we can safely claim that the limit of this function when x approaches to 0, it does not exist.